Wave motion. First lecture, velocity of sound wave. So what is velocity of sound wave? Let us study this. First we study wave motion. What is wave motion? It is a kind of disturbance which is handed over from one particle to other due to repeated periodic motion of the particles of the medium. Suppose I am speaking something, so actually I am disturbing the air particles of the medium, and particle moves, particle vibrates in SHM, and my disturbance is handed over from one particle to another particle, and this disturbance carries the sound energy and you are able to listen. So wave motion is a kind of disturbance, and sound waves in air moves as compression and rarefaction. Compression, rarefaction means कि when I disturb the medium, particle comes closer, it is compression, and then expansion, that is rarefaction. So sound waves moves as compression and rarefaction. And also suppose this is a spring, a jerk is longitudinally, a jerk is given, तो यहाँ compression हो गया. Now this wave is moving, फिर ये यहाँ compression हो गया, ये compression हो गया. ये production of longitudinal wave in spring का example है. This is for air. So types of wave motion, there are two types of wave motion, longitudinal wave motion and transverse wave motion. First see the longitudinal wave motion. When the particles of the medium vibrates along the direction of propagation of wave, wave इधर जा रही है और particle भी इधर ही vibrate कर रहा है, then it is called longitudinal wave motion. Example, sound waves. It moves as compression and rarefaction. You have studied in class 9 also this one. Compression and rarefaction. The wave set up in fluids, liquids as well as gases is longitudinal. Next, transverse wave motion. When the particles of the medium vibrates perpendicular to the direction of propagation of wave. जैसे ये wave है, it moves as crest and trough. Particle vibrates perpendicular to the direction of propagation of wave, and wave is moving this side. Then it is called transverse wave motion. Light waves, all types of electromagnetic waves, X-rays, gamma rays, radio waves, TV waves, all types of waves are called transverse wave motion. When the particles of the medium vibrates perpendicular to the direction of propagation of wave. Example, light waves and all types of electromagnetic waves. It moves as crest and trough. Now note number 1, in solids both transverse as well as longitudinal waves are possible. अगर solid को lengthwise pull करके छोड़ देंगे तो longitudinal waves generate होगा, perpendicular plug करके छोड़ेंगे तो transverse wave होगा. Ripples produced in water are combination of both types of waves. Now next, characteristics of wave motion. Number 1, it is a kind of disturbance. As I told you, if I am speaking something, so I am disturbing the particles of the medium. Number 2, the medium must possess elasticity and inertia. Important for objective also, कि जब ये हम डिस्टर्ब करेंगे तो पार्टिकल डिस्टर्ब होगा और पार्टिकल एसएचएम में होता है, एक्सट्रीम में जाके वापस रिटर्न होता है ड्यू टू इलास्टिसिटी, एंड मीन पोजीशन क्रॉस करता है ड्यू टू इनर्शिया ऑफ मोशन. सो medium must possess elasticity and inertia. Third, it carries energy and momentum. As I told you that the sound air particle carries the sound energy, and if there is energy, the momentum must also present there. So it carries energy and momentum which is transferred from one part of the medium to other without the transport of material medium. Means कि ये vibration से energy carry होता है, ये नहीं कि यहाँ का air has entered your ear, ऐसा नहीं होता. Fourth point, the velocity of particle is different at different position, but the velocity of wave is constant. जो particle vibrate हो रही है वो SHM में, उसकी velocity हर point पे different होती है, mean position पे maximum, extreme पे 0. but इससे जो wave बन रहा है sound wave वो constant speed से move करता है. SHM में सिर्फ particle की vibration थी, but wave motion में particle की भी vibration है और उसकी वजह से wave generate हो रहा है, उसकी भी लेनी है, ये दोनों की combination है. There must be least possible friction between different particles of the medium. जब particle vibrate कर रहे हैं तो इनमें friction नहीं होना चाहिए. Next, सबसे पहले velocity of sound in air was calculated by the scientist Newton. So Newton's formula for velocity of sound in air. So he explained that the velocity of sound in any medium is given as v under root e by rho. चाहे सॉलिड है, लिक्विड है, गैस, किसी भी मीडियम का जनरल फॉर्मूला इलास्टिसिटी बाय डेंसिटी, वेयर ए इज इलास्टिसिटी ऑफ द मीडियम एंड rho the density of medium. Now Newton assumed that when sound wave moves through air, the process is isothermal. मीडियम की टेम्परेचर चेंज नहीं होती. So Newton assumed that when sound waves travel through air, then the temperature of air remains constant. Hence the process is isothermal. So we can use PV is constant is used. Not differentiating. UV method P dV plus V dP is 0. Constant की differentiation 0. ये इस साइड आ गया. P dV is minus V dP. तो ये P हो गया. This is minus dP. ये this can be written as dV by V. देखो V ऊपर चला गया. V dP by dV. You know that this is bulk modulus of elasticity. Stress by volumetric strain. So this is B is bulk modulus of elasticity. Hence we know velocity of sound in any medium is elasticity by rho. So bulk modulus is equal to pressure of air. So V is under root P by rho. And V is under root, we know that pressure or atmospheric pressure is 1.01 into 10 power 5 in SI unit. Newton per meter square. And density of air in SI unit is 1.29. By solving this, he got velocity of sound in air is 280 meter per second. But practical value is 330 meter per second. So actual velocity 330 meter per second. And Newton tried many times, but he cannot found that where he was doing the mistake. तो इसको ये नहीं पता चल रहा था कि गलती कहाँ हो रही है. Then ultimately he leave this topic. Then a scientist came called Laplace, and now very important Laplace correction. Laplace explained that when sound wave moves through air due to sudden compression and rarefaction, the process is not isothermal but it is adiabatic. So PV gamma is constant is used. He explained that when sound waves move through air, then due to sudden compression and rarefaction, the process is not isothermal but adiabatic. Hence PV gamma constant is used, and as we have done in heat and thermodynamics, gamma is ratio of Cp by Cv. Hence velocity of sound comes out to be gamma p by rho. ये heat and thermodynamics में कराया हुआ है ये bulk modulus of elasticity में gamma p आ जाएगा, तो under root gamma p by rho. Newton has calculated under root p by rho was 280 and under root gamma. Mostly air में nitrogen oxygen है, it is diatomic gas and you know that diatomic gas की gamma 1.41 होती है. ये multiply करने पे 330 meter per second at 0 degree Celsius आया, जो आज तक वैलिड है. यही वेलोसिटी ऑफ साउंड का करेक्ट फॉर्मूला है. फैक्टर्स अफेक्टिंग वेलोसिटी ऑफ साउंड, वेरी इंपॉर्टेंट पॉइंट. नंबर 1, इफेक्ट ऑफ टेम्परेचर. सिंस वी नो दैट फॉर 1 mole of an ideal gas PV is RT. Now volume is mass by density of gas is equal to RT. This can be written as P by rho is equal to RT by M. Hence velocity of sound V is equal to gamma P by rho. For P by rho we can write RT by M. So this is the standard formula for velocity of sound in air. And if you get 10 numericals on this topic, so 8 numerical will be solved only by this formula alone. So very important formula. V is under root gamma RT by M. Now you see that V is proportional to root T. Since V is proportional to root T, hence more the temperature, more the velocity of sound in air. So therefore increase in velocity of, so more the velocity of sound in air. Further see that increase in velocity of sound per degree rise in temperature. Per degree rise in temperature में velocity of sound कितना increase होता है, that we have to find. Now velocity Vt suppose अभी room temperature 20 है, तो velocity of sound at 20 divided by velocity at 0 degree Celsius. So it is under root T1 by T2. तो यहाँ 0 degree पे temperature 273 है and at present 20 degree है, तो 273 plus let T is the temperature. So this cross multiplication Vt is V0. This will be 1 plus T by 273 to the power half. Expanding by binomial theorem up to first term, तो ये हाफ आगे आ जाएगा. So Vt is V0 1 plus T by 2 into 273. So Vt is 330. V0, you know that velocity of sound in air is 330. So 331 plus t, multiplying this 546. So multiply this 330 plus 330 by 546. It comes out to be 0.61 into t. So this is the standard formula, that velocity of sound increases by 0.61 meter per second per degree rise in temperature. For example, suppose अभी temperature 20 degree है, तो 20 into 0.6 it will be roughly 12. So velocity of sound at present will be 342 meter per second. Next point, effect of pressure. If temperature remains constant, it is independent of pressure because the factor P by rho remains constant. We know that P by rho is RT by M. Since R is constant, temperature is constant, molecular weight is constant, your mass is constant, so P by rho is constant. So अगर pressure increase करेंगे तो density भी corresponding increase हो जाती है. The ratio remains same. Hence pressure is independent of pressure. So if we plot a graph velocity of sound versus pressure, so it will flat. By increasing pressure, velocity does not change. Next point, effect of density rho. Since we know that V is inversely proportional to root rho, so more the density, less the velocity of sound. Density change होने से pressure नहीं change होती. So V is proportional to 1 by root rho. Hence, more the density, less the velocity of sound. Next, effect of humidity. Now, dry air is more dense than moist air. देखो summer में dry air है. Dry air में यूनिट वॉल्यूम लेंगे तो उसमें डस्ट पार्टिकल होगी. डस्ट पार्टिकल स्टोन पार्टिकल है, वो हाईली डेंसर है. और रेनी सीजन में एटमॉस्फेयर में वाटर पार्टिकल होंगे ये, तो वाटर पार्टिकल लेस डेंस है डस्ट पार्टिकल से. सो इसीलिए रो की वैल्यू डेंस एयर में लेस है. सो देयरफॉर ड्राई एयर इज मोर डेंस देन द मॉइस्ट एयर. Hence the speed of sound in summer is less than in rainy season. क्योंकि summer में density ज़्यादा होगी तो velocity of sound कम हो गया. तो summer में कम होगी velocity of sound, rainy season में ज़्यादा होगी. Note, sound can be heard at greater distances at night or after rainfall because humidity of air increases. क्योंकि humidity बढ़ने से density कम हो जाएगी, velocity of sound increase हो जाएगा. Fifth point, it is independent of amplitude, frequency, loudness, etc. जोर से चीखने से चिल्लाने से ये नहीं कि velocity of sound बढ़ जाएगा. It is independent. Amplitude, frequency, loudness, etc. Next, for numericals. First, कई बार numerical में ratio of density of oxygen by density of hydrogen given होगा. तो density is proportional to molecular weight of oxygen by molecular weight of hydrogen. ऑक्सीजन 32, हाइड्रोजन 2, 16. तो कई बार ये हेल्पफुल होगा न्यूमेरिकल में. कई बार 2-3 गैसेस मिक्स है तो डेंसिटी ऑफ मिक्सचर फाइंड करना है. डेंसिटी ऑफ मिक्सचर इज टोटल मास बाय टोटल वॉल्यूम. टोटल मास m1 plus m2 by total volume v1 plus v2. Now mass is volume into density, mass is volume into density, v1 plus v2. So velocity of sound in mixture will be under root gamma mixture p by rho mixture. ये भी फॉर्मूला है velocity in mixture. Now let us see some example. Number 1, at what temperature will speed of sound in air becomes double of its value at 0 degree Celsius? So we know that V is proportional to under root T. So V1 square by V2 square is T1 by T2. Now V1 square, final velocity double of initial given in question, 2V1 square. Now 0 degree Celsius means T1 273. फाइनल T2 we have to find. So ये V1 square कैंसिल हो गया, यहाँ 4 हो गया, क्रॉस मल्टीप्लीकेशन. T2 is 4 into 273. So 1092 Kelvin is the answer. Suppose the answer we have to find in Celsius. So minus 273, 819 degrees Celsius is the answer. Now example number 2. Show that velocity of sound, ये एडवांस ऑब्जेक्टिव में आया था पास्ट में. Show that the velocity of sound in hydrogen gas gamma 7 by 5 to that of helium gas gamma 5 by 3 at the same temperature is under root 42 by 25. Now velocity of hydrogen by velocity of helium, you know that gamma RT by m, तो T सेम है, कैंसल. T कंपेयर कर रहे हैं तो T हटा देंगे, गैस कांस्टेंट R भी हटा देंगे, तो ये फॉर्मूला बच जाएगा गामा हाइड्रोजन बाई मोलिकुलर वेट ऑफ हाइड्रोजन gamma helium by molecular weight of helium. So under root gamma hydrogen given 7 by 5, gamma helium given 5 by 3, molecular weight of helium is 4, molecular weight of hydrogen is 2. So that is under root ये 3 ऊपर चला गया 21 by 25, 2 से cancel होके 2 हो गया. So under root 42 by 25 is the answer. Next, one more numerical. The speed of sound in hydrogen at NTP is 1270 meter per second. Find the speed in a mixture of hydrogen and oxygen in the ratio of 4:1 by volume. So see that rho, first calculate density of mixture. It is for hydrogen it is 1, 4V into 1 plus, क्योंकि अभी कराया डेंसिटी की रेशियो 16:1 है. फॉर हाइड्रोजन अगर डेंसिटी 1 है, वॉल्यूम 4 पार्ट है, 4V into 1. फॉर ऑक्सीजन इट इज V 1 रेशियो है, V और ऑक्सीजन की डेंसिटी 16 बाई टोटल वॉल्यूम 4V plus 5V. V cancel, so it comes out to be 4. Now we know that velocity is proportional to 1 by rho. So velocity of mixture by velocity of hydrogen will be inversely proportional है, तो density of hydrogen by density of mixture और V mixture velocity of sound in hydrogen is given 1270 under root density rho h given है 1, rho mixture 4 है, so ये 1 by 2 हो गया. So V mixture is 1270 by 2, so 635 meter per second is the answer. Now two conceptual question for a school exam. Rifle bullet travels faster than the sound of shot. The ratio of velocity of bullet to velocity of sound wave is 3:1. Next, इसीलिए फायरिंग होती है तो बुलेट ज़्यादा पहले पहुंचता है compared to the sound. Now air gets thinner as we go up in the atmosphere, but velocity of sound does not change because pressure and rho both changes. तो प्रेशर चेंज होने से रो भी चेंज होता है, तो काफ़ी ऊपर जाने पे वेलोसिटी ऑफ साउंड चेंज नहीं होता. V इज अंडर रूट गामा P बाई रो, दैट इज इक्वल टू अंडर रूट गामा RT बाई M एज लॉन्ग एज टेम्परेचर रिमेन्स कांस्टेंट.